Welcome back, everyone. In the previous video, we left off building a walk cycle, a run cycle, whatever. We were procedurally generating animations on our new armature rig that we have. Now, to this video, we're going to start dealing with, now that we get things animating, we need to get things moving. In this video, we're not going to get the armature moving, but I want to explore one of the ways you can go about it. And this one GDC, I think it's a GDC one. Yeah, it's a GDC video. Is one way of doing it when you're dealing with kind of like procedure generated content. And the way he does it, he has two poses, and he kind of just lerps between the two poses. And he does something called like a stride wheel. And basically, when it's the same idea in the previous video, I said it's a cycle. You know, going 360 degrees. And essentially, the stride wheel is a wheel, and it functions and it moves like a wheel does. In here, like someone asked, commented, asking, is like, how do you do the stride wheel? And it dawned on me after a while, thinking that it's a wheel. Who cares what the stride? Like a stride is basically the distance between the 2 feet, but it's still a wheel. So I went and researched how does a wheel move? Like I had an idea, like, okay, basically it's how much, you know, every time when a wheel rotates, it moves a certain distance. So, and when I went online, I found out the way to measure distance of a circle, like what is the circle? Like, what's the length of a circle? It's the circumference equation, which was pi times 2 times radius. Or it can be just pi times diameter. So if you know the diameter or the radius of a wheel, you can then simply calculate the actual distance around. So that means one complete spin of one complete 360 degree rotation of a wheel is that total distance in units in whatever world unit you use for the radius. So in our game system, we just say 1 unit. It can be 1 meter. I think WebGL can consider it 1 meter of space. But you can really, one can be anything. One can be 1 foot. You know, it doesn't really matter. You can make up any arbitrary meaning to it. But we know we go by 1 unit of distance. Since we know what the distance, since that, we can very easily calculate the distance around a circle using the circumference. And every time we move by a certain, let's say if we do 360 degree rotation of a circle, of a wheel, that means we do that circle length, we move forward by that much length. Let's say if we do only half a circle worth, like just pi, then we only do half the length of the circle moving forward, and same thing going backwards. So in this video, we're going to explore that, but we're not going to explore it with a wheel, because a wheel is very easy to control. You only go forward and we go backwards. We're going to actually move a sphere, and we're not going to move a sphere like how some other things, like I've seen in like past with Unity, where you kind of rotate the sphere forward, and then when you want to turn direction, you kind of just rotate like a top the sphere or the character. And the character, you would actually just rotate the character like a top by the y-axis to go into the direction you want. In this video, we're not going to do that. The sphere is not going to rotate like that when you turn. It's going to rotate based on the angle that you're trying to point to, and it's going to roll in that direction. So we're gonna rotate. We're gonna roll in the direction that we choose, and wherever direction it rolls is the direction it's actually going to move at. So, it's still a circle. It's still a sphere. Is still a circle. It's still a wheel. So we can still take the circumference of a sphere, which is the same equation as a circle, and do the exact same approach as a wheel. So a stride wheel is just a wheel from this video. I'm still having throat problems, but I have a bigger cup of water this time. And this should be a smaller video, hopefully. So in this video, we're going to have this is one of the instances where we need a transform hierarchy, because we want to have a parent object which does not rotate. All it does is transform. All it does is it changes position in 3D space, but it does not rotate. It does not do anything at all. And then as a child, we have the sphere, and the sphere rotates in all these different directions. No matter, it doesn't matter. It just rotates in the direction that it's trying to move toward. Let's see. That's it. And yeah, so we're gonna have the first function we're gonna look at. It's very basic. So we're gonna move 2 degrees at a time. Every frame we're gonna move 2 degrees. Okay, and we end up calculating a rotation angle for it, which we're gonna use the left, which is x, and we want to set the angle. So, and we're gonna multiply the current rotation by this. So we're gonna rotate. Since we know the angle, so we want angle divided by 360. So 1 divided by, with angle divided by 360, it gives you a value between 0 and 1. Like how much around the circle are we going? So if we know how much around the circle we're going, we can then multiply that by the length of the sphere. So if we know how much angle of rotation we're doing, we know how much distance we're actually moving by taking that angle, dividing it by 360, and then multiplying it by the length. And that's it. That's really the gist of a wheel. So if I click refresh and I go here, move ball, as you see, it's rotating, and even though it's rotating, it looks like it's actually moving correctly in 3D space. The simulation is successful. It is rotating at the right speed, so you can change it. So if all you care about is a wheel and moving the wheel, we're done. You can leave. Now, if you want to see how to actually move a sphere, like a marble or something, it's tricky. The multiplication has to be done backwards. I've mentioned this in the previous video. Whereas here I have current rotation multiplied by a new angle. To do it the other way, I need to do it backwards. I need this multiplied by this. So it's A times B, but to do it correctly, you have to do B times A. I don't know. It's like I said, I don't fully understand the whole quaternion thing, but let's keep that in mind. Or do I? Yeah, I think I commented. This is the part. ST, that rotation. P mule. That means I change the order. I do rotation change times old rotation equals new rotation. Like I said, it works here perfectly. You'll see in a minute. But over here it's backwards. I'm just using regular mule. Multiply. Like I said, I don't understand it. I should work either way. It probably can work. I haven't tried. Let's try. P. Let's give it a try. Why not? Refresh. And things break. I think I broke it. Oh, because I'm not using... I commented out a bunch of wrong things. Refresh. It works, I think. Does it? I guess P mural does work, too. All right, so I stand corrected. Empty. Yeah, still works. All right, like I said, I don't understand quaternions. I guess rule of thumbs, do B times A first. Angle of rotation times your current rotation. All right, so in the next version, we're going to add controls to it. So we're going to control the movement with our keyboard. We're going to use the arrow keys. I have a follow camera thing I added. It doesn't seem like it's working, though. But probably only works when I have controls. All right, so first order of business, we got to find out which direction we're going to. So I need Z in X direction, basically. So it's 1 or -1, so on in a direction. If either one equals, if both of them equal 0, exit. That means, there's no motion of rotation. There's no direction I'm going. I'm not holding down a button. So I kind of just saved Z into direction so I can start tweaking with it. Forward is forward. Like I said, since I'm not rotating the parent at all, like I was using get forward rotation or get forward direction of the player. But since I'm not rotating the player object, the parent object at all, forward is always forward. Forward doesn't change at all. So I don't need to do it. I can just say forward. So, like I said, I when I'm prototyping and I start to realize, well, I'm not rotating. Do I really need to calculate forward? Because forward doesn't change. So in this instance, forward doesn't change because I'm not changing parent. The parent stays. The only thing that changes on the parent is the position, not rotation. All right. So, but this might be useful if you want to rotate based on like camera. So if you need the forward, like this works fine if I calculate forward. But like if you're gonna have like a camera, like a follow camera, and you're gonna be behind the ball, and the camera is basically gonna be your thing, like your direction. You can use the camera direction. So, but that's all depends on how you want to do the ball. But for this one, forward is forward. That's it. I don't care based on the camera or anything else. If I'm not moving forward and I'm just turning, I'm just going left and right, essentially. I'm going to change my forward to left and make my X direction equals direction. That's why I'm having the word direction. So if I'm not moving forward at all, I'm just going left and right. I'm just changing my forward direction, and that's it. Because my direction is, like, I don't need to calculate anything. Now, if I'm going forward and I'm turning a direction at the same time, I'm like holding down the up button and the down button. I got to do a little bit of math. I got to rotate the forward by 45 degrees. So if I'm pointing forward, I need to rotate either 45 or -45 by it. So by multiplying by both allows me to do forward left, forward right, back left, forward right, back left, and back right. It all works. Like I said, I'm not a mathematician. I just sat there. I'm like messing around. Things aren't going directions. I just try a couple different things, and it just works. I tried a bunch of different if statements, and that worked. And I tried to simplify it, and I managed to actually see. I think I managed to see kind of a pattern, and by doing that, it worked. So that's great. So, because if I'm going forward, I have a positive, and if I'm going left, I'm going positive. So it's always going to be a positive 45-degree angle. And if both directions are negative, it becomes a positive anyway because you're multiplying, and it becomes so. I don't. It just works out. I guess I can't explain it. It just works out. Like. That's it. That's a new meme. All right. So now that I know which direction forward is, I scale forward by speed that I'm going to, which is angle, replacing angle with speed because it's an angle of speed, and by the step. And the step I have up here, it's the same stuff as here. I have angle divided by pi times sphere. I'm doing this so this way, instead of using division, I can turn this one division into multiplication. So this part replaces this part. So I can put speed here and the same value because everything kind of goes in order. So I just might as well just throw that in there at the very end. So this way I can keep the equation easy. So it's just speed times increment, the actual step movement. We're translating the angle to actual distance that you move. And then by direction, like I said, direction could be positive or negative. So based on what direction you're currently going to, that's direction that we're trying to get to. And then just say I want to update the parent. That's the parent transform. Now that we have the moving working, so why not we just do that? And let's just show off that moving works. Who cares? Let's not bother. Moving doesn't matter unless you see the rotation happening. All right. Now that we know the forward rotation, so we know which direction it's moving. If you want to rotate correctly, let's say if we're moving on the z-axis, if you're moving on the z-axis, you run and rotate on the x-axis for a wheel. That's how it works. That's how it works essentially. So if I know what my forward axis is, I need to know what my left axis is to rotate. So if I'm moving a circle or moving a sphere, moving a wheel, if I'm going forward on a certain axis, I want to know the axis that's 90 degrees of it. So I'm just rotating my forward axis by 90 degrees, which is pi half. And I'm rotating it by the y-axis. So I'm just going to just turning it by 90 degrees, and I'm normalizing it. I need to normalize my quaternions to make them... Oh, no, wait. No, that's just a direction. I'm just normalizing. So this way I can add my that direction as the axis, because the axis should be normalized when you use it for quaternions. So I know what my speed is and I know my direction, so it's the same value as pretty much up here for position. So I'm just taking away the step because of that. Since I know what my change rotation is, I know the axis of rotation, and I know how much to rotate by. Like I said, it's that angle of rotation, and speed's up here. Where's speed? Speed's here. Space bar, I use speed. If I have the space bar on, I do speed fast. So I'm going 5 degrees of rotation for slow, and I'm going 15 degrees of rotation. And that whatever length it is, you just, like I said, it's a circumference equation. And then just p mule that change with the current rotation, and that's it. And we're done. So if I click refresh, I can go left and right. Remember I said left and right? I don't bother calculating. I just change it to left and right. That works. Forward and back, and the follow camera is working too. So the camera's following the ball. This is great. So if I hold forward, and I rotated the camera, so I'm actually behind the ball. So if I press forward, I'm actually going in the positive direction on Z. So if I hold forward and right, I go at an angle, and it's rotating in the right angle of axis. And I can go that way. I can press back. I can then hold lifts. Now I'm going diagonal at 45. So there you go. That's it. So if you're gonna try to do that animation when you have the stride wheel, I guess just treat it as a wheel. That's it. That's the simple solution to that. Now if you want to make BB8, this is the code for you. I was thinking about adding a little head on the top, and then if he's moving forward, maybe tilting the head in the direction that's moving, so he's kind of like BB-8 a little bit. But I'll leave that to you guys. I would love to see someone try to turn this into a BB-8 WebGL example, especially if you have a mesh that you can add to the head or something. But yeah, there you go. And like I said, it's parented, so you can just add something there, lift it up, and then you can rotate it very easily and get a really good BB-8 thing going on. I could probably do it, add a sphere, or I had a cube, but I don't feel like making a bunch of mistakes on video and then have everyone laugh at me. Because I like having the code prepared, so I look smart when the code's prepared. When I'm making the code, I'm really an idiot. So there you go. That's it. This is like I said, I'm not using this to actually move my armature. I'm actually end up using a different solution, which is in the next video I'm going to record when I'm done with this. And that's kind of cool if I do that. But yeah, if you want to move a wheel like a car, and you want to basically use the car physics you can. Like, let's say if you make the back wheels move, and you can make the wheels like dynamic, right? So you can make the wheels like big and small, and based on the rotation of those wheels, it's how fast you're going. So this way you don't have to calculate the speed. So like, I'm not really calculating the speed. Like, let's say I can hold a space bar, and there you go, and I go faster, because I'm just rotating the angles faster. Instead of like going 5 degrees per frame, I'm going 15 degrees per frame. So if you want to make a car, this is the deal for you, you know, because now you don't have to calculate the speed of your car. Just make your wheels. Like, if you want, like, basically like a physics-based type of movement, you rotate the wheels, and based on that rotation of the wheels, that's how fast you're really going to go in this 3D space. So, yeah, this is great stuff. Now, when I want to make a car, I got some of the code I need. I might actually like once I have springs, I want to be able to do springs and a little bit of physics. I have like an idea for a kind of a cool thing where I have a sphere as the front wheel, then I have like two massive like wheels in the back, like a Batmobile, like kind of like the Tumbler has like these big huge wheels in the back, and have a sphere as the front, and then just as the. And how cool it'll be, since I can rotate in every direction, this one determines what direction we're going, and then the wheel just pushes you forward. I'm just thinking, how cool will that be, you know? That's a cool idea. So one day when I have spring physics, maybe I'll build like a you know, I'll use some rectangles and spheres and cylinders, and I'll just build a car. And use a sphere as the front wheel. So, yeah, I don't want to make this video too long. Can I tell? Yeah, it's 22 minutes long. All right, so that's it. Like I said, this is great locomotion for a car or BB-8. Go ahead and make BB-8 for me. I want to see it. I want to see a YouTube video. I dare you. Do it. Do it. All right, stop acting creepy. All right, so the usual BS. Like and subscribe, and I'll see you in the next video, which I'm actually going to make our armature run in 3D space. We're going to follow the same kind of approach. We're going to do more of a physics-y, I think it's physics, because you put the foot on the floor, the foot moves, and your body moves at this pace of that foot. It's like the same idea. I'm moving it based on rotation, and in armature, we're going to move where the foot tells you to move. We're not going to just make it slide forward. It's not going to slide. It's going to physically move itself. So that's going to be the next video. That one's a really great one. That one I was bouncing up and down because when I got it to work. It's really great. I love it. I don't know. I love this. This is fun. So little by little, I'm going to build that IK rig system from Ubisoft, and then Ubisoft's going to be pissed off and sue me and tell me take that off the internet. I don't know. They'll never do it because I'll never be my system will never be near as good. But you can only hope. I can only hope, right? You got to try. You can't sit there and just give up. You got to try. That's like my new motto in life. Just try. Just try everything. Just throw the kitchen sink at it. See what happens. You get happy accidents sometimes. Sometimes you get really happy accidents. So, wasting too much time. I wasted like maybe another minute or two rambling. So, I'll see you guys in the next video where we're actually going to start moving our armature in 3D space.